Dear learners, I welcome you all on SWAM platform. Today's lecture is going on geothermal energy power generation. Before the start of this lecture, let us recall about the previous lecture of biomass and biogas power plant. In the previous lecture, we have already discussed on the basics of biomass and biogas energy and its formation, sources, properties, utilization, and biomass and biogas, principle of biogas production and various biogas plants, site selection for the biogas plant, advantages, limitations, and utilization of biogas. Now in this lecture, we will focus on the following contents: introduction to geothermal energy, what is geothermal energy, geothermal reservoirs, geothermal resources, how geothermal energy is captured, how does geothermal energy work, extraction and use of geothermal energy, dry steam plant, flash steam power plant, binary cycle power plant, geothermal energy in India, advantages, disadvantages, and future of geothermal energy, the environmental impact of geothermal energy, and we will also discuss about the conclusion. Now let us start the lecture. Introduction. What is geothermal energy? It is the simple heat energy of the earth generated by various natural processes such as heat from when the planet formed and acidity which has not yet been lost, decay of radioactive elements, friction, etc. The deeper you go, the hotter it is. The diagram shows the level of increase in heat with respect to moving deeper in the earth's from crust to the core. Geothermal energy is the heat that lies within the earth. This heat energy is obtained from the hot rocks present inside the earth. Geothermal stands for geo, that is earth, and therm means heat. This renewable source constantly producing heat, thus making it inexhaustible to mankind. Almost 4,000 miles beneath the Earth's surface, this phenomena known as geothermal energy gets generated deep inside the Earth's core. The diagram shows the various forms of the surface of the Earth, that is crust, and beneath it mantle and then core. Core is where the hot magma is there. What is geothermal? Here the earth crust broken into several pieces called plates. Magma comes to the earth's surface near to the edge of this plate. In this plate, volcano occur. The lava that erupts from the volcano is partly magma. Deep underground the rock and the water absorbed the heat from the magma. The temperature of rock is increasing around the depth. This diagram shows the volcanic eruptions from the inside of core coming out of the earth's, that is crust. Here the question arises, how does it comes to the earth's surface? The heat from the earth core continuously flown outward. It transfer or conducts to the surrounding layer of rock, the mantle. When temperature and pressure become high, some mantle rock melts, become magma. Then because it is lighter, less dense than the surrounding rocks, the magma rises or convects, moving slowly upward the earth crust, carrying the heat from below. Is the geothermal energy renewable? Yes, indeed, it's a renewable energy. The energy keeps on coming as long as we don't pump too much cold water down and cool the rocks too much. Geothermal reservoirs can be suspected in the areas where we find geyser, boiling and mud pot, volcano, hot springs. This diagram shows the various spots where the mud point, the geysers is available on the crust. Geothermal reservoirs, rising hot water and steam is trapped in the permeable and porous rock to form a geothermal reservoir. Reservoirs can be discovered by testing and soil analyzing underground temperature. This diagram shows the geothermal energy hotspot taking and using the cold water and rising the temperature of it. Naturally occurring large areas of hydrothermal resources are called geothermal reservoirs. Most geothermal reservoirs are deep underground, with no visible clue showing above the ground. Geologists use different methods to find geothermal reservoirs. The only way to be sure there is a reservoir is to drill a well and test the temperature deep underground. Geothermal energy sometimes find its way to surface and to form volcanoes and further fumaroles. This diagram shows the working. One side, the left part of the diagram shows the working of the geothermal part, and the second shows a fumarole. Fumarole is a hole which allow us to take out the heat from deep into the earth. Active geothermal resources usually found along the plate's boundary where volcano and earthquake occurs. Most geothermal activities in the world occur along the borders of the Pacific Oceans, called the Ring of Fire. The energy produced mainly using water, hydro or heat thermal, is called the hydrothermal energy, depending upon the temperature of the hydrothermal resources. The heat energy can be used for heating, making electricity, or a heat pump. The diagram shows the line of fire. Here it is in the Pacific Ocean. One side the Japan is there, and another it is between the United States, covering the entire Pacific from the Japan to the east and from west, that is the United States. The different geothermal energy sources, as the name implies, these are the reservoirs of hot underground water. There is a large amount of them is in the US, but they are more suited for space heating than the electricity production. In this case, a hole dug into the ground can cause steam to come to the surface. This type of reservoir resources is rare in the United States. In this type of reservoir, brine completely saturated with natural gas is stored under the pressure at the weight of the overlying rock. This type of reservoir can be used for both heat and for natural gas. The diagram shows the different hotspots of the natural reservoirs. A normal geothermal gradient is a place on the planet where there is a normal temperature gradient of plus 30 degree as per kilometer dug into the earth. Therefore, if one digs 20,000 feet, the temperature will be about 1900 degrees centigrade above the surface temperature. This difference will be enough to produce the electricity. However, no useful and economical technological has been developed to extract source of energy. This type of condition exists in 5% of the India. It is similar to the normal geothermal gradient, but the gradient is 40 degrees Celsius per kilometer dug underground. This diagram shows the hot rock segments. The most current way of capturing the energy from the geothermal sources is to tap out naturally occurring hydrothermal convection system, where cooler water gets down into the earth crust, is heated up and then rise to the surface. When this heated water is forced to the surface, it is relatively simple to capture that steam and use to drive electric generators. Geothermal power plants drill their own holes into the rocks to more effectively capture the steam. How does the geothermal energy works? Hot rocks underground heat water to produce steam. We drill holes into the hot region. Steam comes up, is purified and used to drive the turbine, which drive electric generator. There may be natural groundwater in the hot rock anyway, or we may need to drill more holes and pump water down to them. This diagram shows the working of a geothermal power plant, from taking the hot stream and the hot stream converted into the steam using the flash then from steam to the generator, and when the generator makes the electricity, again the water will go into the cooling tower, and then after getting it cooled, again we get again it's sent to the injection well. The heat energy can be brought to the earth's surface by the following ways, that is from direct hot spring or geyser or the geothermal heat pumps. Their use are broadly classified as direct use and indirect use. The direct use of geothermal energy, we can find it as hot spring used as spa, heating water as fish farm, provide heat for buildings, rising plant in greenhouse, drying crops, provide heat to industrial processes. The diagram shows the heat which we can obtain in both the seasons. In winter, suppose if we are getting the geothermal energy of 18 degree, then in the summer where the surrounding temperature is 10 degree, we get the hotter water that is of 18 degree. But when the summer season, the 18 degree water works as the cool water because the surrounding temperature is 30 to 35 degrees Celsius. Direct use of geothermal energy can be used as geothermal springs can also be used directly for heating purpose. Hot spring water is used to heat greenhouses, to dry out fish, and to de-ice road for improving oil recovery, and to heat fish farms and spas. The direct use of geothermal energy is appropriate for sources below 150 degrees centigrade. Air conditioning, industrial process, greenhouses, aquaculture, hot water, resort and pools, melting snow. The diagram shows the various locations of the hot springs and geothermal spots around the globe. A much more conventional way to tap geothermal energy is by using geothermal heat pump to provide heat and cooling to the buildings, also called ground source heat pump. They take advantage of the constant year-round temperature of about 50 degrees Fahrenheit that is just a few feet below the ground surface. Either air antifreeze liquid is pumped through pipes that are buried underground and recirculated into the building. In the summer, the liquid mover heat from the building into the ground. In the winter, it does the opposite, providing pre-warmed air and water, the heating system of the building. However, the ground source heat pumps are catching on in some areas. In rural areas without the access of natural gas pipeline, home must use propane or electricity for heating and cooling. This is show the heating of the geothermal energy taken by a household. Indirect use of geothermal energy can be done using electricity generation. Electricity generation, there are three types of geothermal plant which results in the electricity generation: the dry steam power plant, flash steam power plant, binary cycle power plant. For the dry steam power plants, this diagram shows the schematic sketch of working of dry steam power plant. The oldest type of geothermal power plant, it is reservoir containing pure steam. Purely dry steam drives turbine, very rare type of geothermal power plant operating at California, Italy and Japan. Flash steam power plant. The diagram shows the working of flash steam power plant from injection from the hot stream, passing through the pipe and attached to a generating facility, then again getting in the injection well. Commonly used geothermal plant. It is the commonly used geothermal plant. This geothermal reservoir contain both hot water and the steam. Pressure changing system is required for the operation. This plant is operating currently in Hawaii, Nevada, Utah and some other places. Binary cycle power plant. In this is similar to the previous one, but here we can find the binary cycle system. It does not use steam directly to spin turbine. Only the heat of the underground water is used. Vaporized carbon, hydrocarbon are used in spin the turbine. Hydrocarbon having lower boiling point such as isopentane, isobutane and propane can be used. In this plant, no harmful gas is emitted to the atmosphere because the underground water is never disclosed to outside. This is the world accepted power plant. It is the direct use of geothermal energy is absolutely cheaper than other energy sources. Geothermal energy in India. The map showing the various spots where in India the geothermal energy is available beneath the ground. Geothermal provinces. The location where these spots are available are called as geothermal province. Geothermal provinces are estimated to produce 10,600 megawatt of power, out of which the experts are confirmed and confident about 100 megawatt. In India, geothermal provinces in India are Himalayas, Sohana, West Coastal Bombay, Son, Narmada, Tapi, Godavari and Mahanadi. Reykjavik Geothermal will assist the Thermax to set up pilot project in Punga Valley, Ladakh, Jammu and Kashmir. Geothermal energy refers to the heat stored beneath the Earth's surface that can be harnessed to generate electricity or to use directly for heating and cooling. While it has several advantages and also comes with its own set of disadvantages. Here are some of the key advantages and disadvantages of using geothermal energy. The geothermal energy is a renewable and sustainable source of energy that can be continuously replenished, as the heat within the earth crust is essentially limitless on the human time scale. Though it is sustainable and renewable, geothermal energy typically generates very low emissions of greenhouse gases and other pollutants compared to the fossil fuel based energy source, contributing to lower air pollution and reduced carbon footprint. Hence, it is the energy source which is create very less emissions. This geothermal energy power plant generally have high availability rates, providing a stable and consistent source of energy, as they are not dependent on weather conditions like solar and wind energy. So it is a reliable source also. Once the geothermal power plant is built, operational costs are relatively low, as geothermal energy consistent and stable source that does not require fuel, transportation or combustion. So we can say this is also a working at low operating cost source of energy. Geothermal energy can be used for various purposes, including electricity generation, heating and cooling. It can also be utilized for agricultural and industrial process, making it a versatile energy source. So we can say, by seeing the advantages, that the geothermal energy having less emission, sustainable and reliable, renewable. And now let us discuss some of the disadvantages. Geothermal energy comes with little disadvantages too. The geothermal energy sources are not uniformly distributed globally. They are mostly found in the specific region, limiting its widespread adoption and accessibility. The initial cost is the upfront cost of drilling and building geothermal power plant can be significant. The exploring and drilling expenses, especially in the area where uncertain reservoir potential, can add to the overall cost. The potential environmental impact. Geothermal energy extraction can sometimes have negative environmental impacts, such as the release of hydrogen sulfide, carbon dioxide and other gases. Improper handling of geothermal fluid can also lead to the release of toxic materials, resource depletion and decline. The over extraction of geothermal fluid can deplete the reservoir over time, leading to a decline in energy productions. This can result in the need of fuel exploration or the development of new sites. It also associates the geological risk such as earthquakes and potential for releasing dormant volcanoes can be associated with the extraction of geothermal energy, especially if not managed properly. On the main limitations of geothermal energy, it is dependence on geographical locations. Not all regions have the stable condition for harnessing geothermal energy efficiently. The accessibility of geothermal energy resources is largely dependent on the proximity to tectonic plates, boundaries, and geological features that allow for the natural heat from the Earth's interior to be accessible. Consequently, many countries and regions do not have the geological characteristics necessary for cost-effective and efficient geothermal energy production. Overall, while geothermal energy has significant potential as a renewable energy source, its limitations related to geographical constraints, initial investments, cost, and the need for sustainable resource management highlight the importance of careful planning and assessment before undertaking geothermal energy project. The future of geothermal energy look promising with ongoing advancement and research aimed all overcoming its current limitation and making it a more widely accessible and acceptable cost-effective renewable energy source. Several developments and trends reshaping the future of geothermal energy. The ongoing technological advancements such as enhanced geothermal system, EGS, and advanced drilling techniques are expected to expand the potential for geothermal energy production in regions that were previously considered unsuitable. The innovation aims to make potential energy more accessible and cost-effective, thereby expanding its use in various regions around the world. Growing awareness of the important renewable energy source and the need to reduce carbon emissions has led to increased investments in geothermal energy projects. Connection to the private sector, investments are expected to further drive the development and the deployment of the geothermal energy technologies, leading to an increase in geothermal energy capacity globally. The geothermal energy is increasingly being integrated with other renewable energy sources and energy storage technologies to create more reliable, resilient energy system. This can help address the intermittency issues associated with some renewable energy sources, making geothermal energy an integral part of the further sustainable energy grid. The development of the sustainable practice and resources management techniques to gaining importance in the geothermal energy sector. Efforts to minimize environmental impacts, promote responsible reservoir management, and ensure long-term sustainability are likely to be key factors shaping the future of geothermal energy development. Favorable government policies, incentives, and regulatory framework that encourage the development of geothermal energy are crucial for its future growth. Policy support can help mitigate the initial high costs of exploration and development, making geothermal energy more economically competitive with other energy sources. Overall, with continued technological advancements, increased investments, and supportive policies, geothermal energy is expected to play a significant role in the global transition to more sustainable and low-carbon energy future. As efforts to address climate change intensify, geothermal energy's reliable and low emissions characteristics positions it as a key renewable energy sources for meeting the world's growing energy demand. Now let us discuss about some environmental impact of geothermal energy. Geothermal energy is generally considered to have lower environmental impact compared to other forms of energy generation, particularly fossil fuel. However, it is not entirely without environmental consequences. Here are some of the environmental impacts associated with the geothermal energy. The geothermal power plant produces significantly fewer greenhouse gases emissions compared to the fossil fuel power plant. This is because they do not burn fossil to generate electricity. The emissions primarily consist of the carbon dioxide, but in much smaller quantities than the fossil fuel plant. While geothermal power plants have lower environment emissions of sulfur dioxide, nitrogen oxide, and a particulate matter compared to the fossil fuel plant, they can release trace amount of hydrogen sulfide and other volatile organic compound which can have localized air quality impact and odor. The land footprints. Geothermal power plant require land for their facilities including drilling, site and infrastructure, while the land footprint is relatively small. Other forms of energy generation, there may still be land use and habitat disruptions in the vicinity of geothermal power plant. The geothermal power plant require a significant amount of water for cooling and heat exchange. The availability and uses of water can be concern in regions with limited water resources. Over extraction of geothermal fluid from the underground reservoir can lead to resources depletion and potential results in land subsidence. Careful reservoir management and essential to prevent these issues. Geothermal energy operates can induce small earthquakes, primarily in the areas with enhanced geothermal system where fluids are injected into the ground to create or enhance reservoir. These induced seismic events, though usually minor, can raise concern. Discharge geothermal fluid may be warmer than the receiving surface water, potentially cause geothermal pollutions in aquatic ecosystem. This can disrupt local ecosystem and impact aquatic life. It's important to note that the environmental impact of geothermal energy can vary based on several factors including the technological use and quality of the resource and the location of the geothermal plant. Proper planning, management and regulation are essential to minimize negative environmental effects. To many other energy sources, geothermal energy remains a relatively environmental friendly and sustainable option. Moreover, ongoing research and innovation in the geothermal energy sector aims to reduce these impacts further and enhance the sustainability of geothermal energy production compared. So dear learners, today we have discussed on the introduction about geothermal energy and its resources, how does geothermal energy works, its extraction, uses of geothermal energy, types of geothermal power plant, advantages, disadvantages, and the future of geothermal energy. The environmental impact of geothermal energy. Now we can also conclude the geothermal energy is a very sustainable and very less emission at the source of energy. We also know the limitations of the global availability of the hot springs and the regions. Now in the next lecture we will discuss about the power generation from OTE, that is ocean tidal electricity and tidal. Thank you.